Yeah.
Okay, give me a second to write that down. I think you guys should have seen questions like this in advanced functions. I did these in grade 11, so you've seen these all the way back. Right? Seen these all the way back to that. On the assignment, I gave you the equation. This one, I'm getting you to make the equation. Okay, this is like a half-life equation or something like that. Think back, or like even like the pain equation back to money. C times the dot is C times theta to T. And nobody make a joke about cats, okay? That's just the way it worked out. I didn't mean to do that, okay?
It says cat.
Determine the algebraic model for this culture, okay? So the thing is, we're given some information, we're not given everything. I'm going to give you a second here to scribble that down, and then we'll do it together, okay? And think back to your, I'm going back to grade 11 because I've taught grade 11 15 times or 20 times, and I've taught advanced function once. So I'm going to go back to grade 11 here. Think of your pain equation. Does anyone remember the pain equation? No, the money equation, compound interest. Right? Remember that? It was something like this, right? Hey, you don't have to memorize it, okay? I'm not getting you to memorize this thing, okay? But this equation is going to look something like that. Going back from here, which one was the starting value, which one was the ending value? Does anyone recall? Good. Okay. This is going to be your end, and this is going to be your time, right? Now, you don't need to memorize that, but it's going to help you in this question, because every exponential function works the same way, okay? The starting value is going to be the thing outside the bracket, so in this case, the starting value is going to be what? C. C is going to be your starting value, and I'm going to write that down. Okay, what's my C value in this case, please? What's the C value going to be? What's the starting value? 300. P is going to be what? What's P going to be in this case? In English, and then what the number is going to be. P is going to be the end value, and it's going to be 200. T is going to be time, which is this 4, and A is going to be your multiplier. And I just wrote the pain on the board, so hopefully that would remind you back. Well, just because for this equation here. You know what I mean for this one. So I'm going to get rid of this so no one gets confused. Okay, right? But it's the same idea as pain, right? Like the same logic, right? Okay, can I get someone who's brave, who hasn't raised their hand yet today, who I not picked on yet? Chris is down, so I'm going to give you the day off today, Chris, because you've starred in every other day this year, okay, so that's a good thing. Can I get someone other than Chris to be brave and to sub some numbers into the equation? Yeah, go ahead.
Okay, so you start with 700.
Yeah. Okay, so let's see, because the thing is for this, we have to get our unknown value, which is going to be A. So can somebody please tell me how I would solve this question? What's the first step? Solving for A. Nathan, go.
By 8.
Good, so divide by 800, I think that's 9. Is that right?
That is correct.
Okay, stay with me here, please. This is the last example of the year. Oh, go ahead. You could, I'm not going to though. You want to log both sides? Oh, fine.
You could just ask for
I was going to do the fourth route, but you can log if you want to. So you guys want to do, hold on a second. So we can log both sides. We can go log 9 equals log a to the 4. Is that right? Is that right? Yeah, I don't know if I really like this one. Do I like that? I don't really like that. Yeah, I don't like that one. I don't like that one.
Just take the fourth.
I'm going to take the fourth route instead. We're going to get to logs. I'm going to do it like this instead. Only the problem with logs there, guys, is because you log A and you can't get rid of that nicely. Okay, so we're going to go for that. So can someone answer that question? Go ahead. You can use either one. As long as it's consistent on both sides. Right? You can use log base 2, you can log whatever, but log number is base 10. So as long as you're consistent on both of them, all the log rules apply for that. Okay? And I'm a hand copy today, sorry. Okay, 9 to the power 1/4. Jason, can you get the power of your calculator? Give me an answer, please.
1.16529.4.
A little slower, 1.16.
Yeah, 1.16.
So keep going.
65290.
Uh-oh.
You guys are all wrong.
Hey guys, what'd you get?
I got 1.732.
Exactly.
No, there's a 0 after.
050808.
Which is almost root 3.
Oh, I got that now.
Got that now? Good. That's good. Okay. So basically my equation then, therefore my equation, I'm going to say is P is equal to 800 times 1.732. We should use as many decimals as we can. I'll use that one though for right now, 1.732. That's close enough. Okay. Okay, sort of okay? Yes. Now this is where we're going to get to, actually do an easier one here. We're going to start for part B. We're going to say, find the number of bacteria after 6 hours. Six, yes. Okay, so this is one of the ones that was not photobombed. I want to say R-bombed last night, okay? How do we find the number of bacteria after 6 hours? Go ahead.
Well, because it's hours, we have to change it into minutes.
No, not in this case, we don't. Because everything's just an hour 13 beginning.
Oh, okay, so then you just replace T as T6.
Yeah, good. So it's going to be, P is going to be 800 times 1.732. Now, if you wanted to do minutes, originally, Chris, you just would have made your time 4 divided by 60. And it shouldn't use minutes, right? Or, no, 60 times 4, sorry, 240, right, for 240 minutes. Okay, so can I get somebody who's going to be the best crafter in this class to do one, so as far as bed mass goes, 1.732 to the power 6 times that by 800, please. 216. Exactly?
Yeah.
Can we confirm that?
Yeah.
Perfect. 1.732 is very close to the root of 3. That's why I think that works out nicely. Okay, here we go. Letter C says, find the average rate of change. Oops. That's the instantaneous rate of change first at 5 hours. Okay, so here we go. as soon as you hear the word instantaneous rate of change, what are you thinking? No. Death. Derivative, thank you. Okay. So you're thinking, hopefully, P prime. I'm going to hit pause in the video, and I want you guys to find the derivative of this for me, please. Okay? I'm stopping the video. So if you don't have it by now, that means that you forgot how to do this, which is okay. What's the derivative of 1.732 to the t?
0.
No. Go.
T times 1.632 to the power of t minus 1.
No. All right, Emma. Yes. What's the best? This example is like the greatest thing. Okay, so I know you guys are thinking t minus 1. I know what you're trying to do there, but remember for the variable, whenever there's a base that's not equal to e, like if it's like an exponent, just whatever the base comes down to ln of that. Okay. So if I want to know the rate of change after 5 hours, what do I do? 7.5, right? Okay, this is a big number. It's going to be. Sorry, Tori, you have a question? I didn't understand you.
I don't understand why the 1.73 was the one that got brought out.
Okay, so imagine if this is just the rule. So let's say I'm doing 5 to the x, right? That's an original function. That's just going to be ln 5 times 5 to the x. Okay, let's say it's 5 to the 3x minus 2. That's ln 5 times 5 to the 3x minus 2 times 3. Right, because it's ln of the base times the original function, then times the derivative of the exponent.
Okay, so that I can kind of understand, but almost because,
We're good?
yeah,
Okay.
I
It's just a little different because the numbers are messier and it's
it was the brackets
Yeah.
that actually messed me
Okay.
up because, yeah,
okay.
in our other examples, we cracked out.
Sorry, no, you got it for me? Sorry, Brendan, you got it for me?
Well, I have a question.
Oh, yeah.
Why do you keep the 800?
Because think of it if it was like 800x squared, that's times, right? So let's pretend it was 800x squared. That would be 1600x, right? You know what I mean? Because just the coefficient comes, if it was plus, if it was added or subtracted, you get rid of it. But because it's times, it stays. Yeah, it's times, it stays in. Okay, can I get a brave volunteer to please bravely finish this question off and finish the year? This is the last example for the year. Go ahead. P prime equals?
Subject, right?
Yep.
I guess 7,850.
That is correct. Now that's the rate of change. What does that mean in English? Yeah, so we say therefore at 5 hours the culture is growing at 6850 per hour. Right, that many, you know what I mean, that many things per hour. And you can see why it'd be exponential for anyone that's in biology. Do you guys do that, Mr. Craig? Do that where he does and it grows and it gets bigger than the thing. Right? And that's why it's exponential, right? So it's like that. You got somewhat help? The only thing that was getting you was the 50%, right? That was it's the same question.
That's not the same question. That was way easier.
That's very close to the same question, isn't it?
No, it's not. No, let's talk about percent.
Percent, just leave is 50 equals. So the question on the assignment was that number 2. You just want to solve this equation. whatever it is to the T. Whatever, something like that. I don't know what the decimal, I don't know what the number is in there, but.
Why is it okay to have a decimal here, but every single other one we have to have the exact number?
Why would it be 50? Why wouldn't it be?
I'd give you 50. I'd give it. Well, it turns into a half because you divide by 100. Right?
Yeah, but it said. No, that doesn't make sense.
Does this make sense?
No. It says 50%.
Well, 50 is a percent and 100 is a percent. That's what we're saying. I know what you're thinking. Go with this. Go with this. I will not be confusing on the test. Yes. Yeah, 7, 8. Okay, can I talk here, please? So Tanner, stay with me. 7, 8, 9, and 10 are the ones of the related rate questions, right? Those are related rate questions. Tomorrow, I'm planning to do maybe a related rate question or two. I just want to make sure, though, that if you guys need time to work on this, I'm going to try and get a little bit of time, even though I gave you last weekend as well. So I'm going to try and aim for half the period to give you guys to work tomorrow. I'm going to do a related rates question. If you need to bring headphones tomorrow, do it. If you need to sit in the corner by yourself instead of with your friends, do it. If you need to, you know what I mean, whatever you need to do for tomorrow's fine. If you guys just want to work period, I can do that as well. But I wouldn't mind doing at least one related rates question to make sure you guys got it. Bailey, go ahead and then.
Can we do a question that's like number 4, like the water?
Yeah, I can do one of those tomorrow, no problem. I can do those, no problem. Yeah. Yes. So ask me tomorrow. Okay, so we'll do. I'm gonna give you guys. Do you guys want to do those now, or do you want me to do them after? Do them now. Okay. So this is test review. We'll start. Can I see somebody's homework sheet from earlier this week? I want to make sure I get enough questions. Remember that sheet that I gave you 3 questions on? What is the I hope this is enough information here. Try this one out here. Okay. So this is like that cone question I gave you guys for homework. I hope you all did it. Okay, right? But if you didn't, this is one that's very much like it. Okay. So it says water is being poured into a cone at a rate of that. The question on your sheet was being drained. It's the same thing, plus or minus. Okay, what is the rate of change of height of the cone at height 15 centimeters? So when the height's 15 centimeters, what's the rate of change going to be? Okay, let's start with a drawing here. Yeah, this is the only thing I'm wondering if I should tell you that the height is the same as the radius. Should I tell you that? I think maybe for this one, I'm going to assume height equals radius. I'll get another one tomorrow, because I think that we'll need this one. This isn't an angle to vertex questions. We're going to say for this one, the height's going to equal the radius. It's going to be a perfectly even for this one. Okay. Okay, what's some information that we have here? I asked for 3 different volunteers. Luke, is there anything I know from here?
The rate of change.
Good. Of what?
The height.
The rate of change of height is going to be unknown. So I'm going to say dh by dt is unknown. What else do I know, if anything? Somebody else, what else do I know? Go ahead.
dv over dt is 5.
Good. So dv over dt is 5. It's getting bigger. What else do I know? One last thing. M, is that a hand or just a scratch on the forehead? It's a hand. Height is 15, which is actually going to be my radius too, just for this question. So I'll get a good one tomorrow. For that. Okay, can someone please be brave and give me the, if you guys have your formula sheets out, which I hope that you do.
How do you know what has to be, like, how do you know
Okay, just wait, because we're saying here, as soon as you see this is per minute, that's going to be like volume per time, right? So change in volume over change in time.
Okay.
That's the units then. So everything's going to be
So then
Easy.
because you're trying to find
the change in height, the change in height.
So
There-
it's always gonna be over like
Generally, it will be if it says like per minute. Like I'll try and be consistent.
so if it has a time in it, it's
Yes.
always over dt.
Yes. Yes. What's the volume of a cone? Everyone else tops their head. I want to say it's 1/3 pi r squared height. Does that sound good to you guys?
Yeah, yeah.
I think that's right. Okay. Now I gave you this information, and I think you need it. The other thing I could have said is the radius is equal to something a different number here, okay? But we'll leave that in there for right now, okay? So I'm going to call this in volume is going to be 1/3 pi h cubed. Why am I allowed to do that in this case? Yeah, go ahead.
R equals 5.
Yeah, r equals h, you said, right?
That's
Okay.
what
Yeah, r equals h, so I did it in this case. Now, the other way I could have done it is I could have said the radius is equal to 20. When the height is equal to 15 and the radius is equal to 20, then the radius would just be a constant. Okay, so you could have just subbed that in. But we'll leave it like this for right now. Can someone please be brave and take the derivative of this? What's the derivative of capital V? You're brave, go ahead. dv over dt. What's the derivative of 1/3 pi h cubed? Yuck. Go ahead.
Is it by chance
That's the first one.
1/3 pi 3h to the 2?
Yeah.
And then times dh over dt.
Wonderful. Now I'm going to take a step back to make sure this is good for people. Cecilia, how are you feeling about the world? Okay. How's Canada's Wonderland? Fun at least? Okay, good. Okay, but for h cubed, everyone remembers that changed to 3h squared times dh dt. Okay? Michael, go ahead. Well, that's just a number. Like, it's like all these, this is like a coefficient. Right, but only if you add or subtract them, right? Like, because this is this times h cubed. You know what I mean? So this is just going to neaten up. I'm going to call that dv by dt equals pi h squared dh over dt. Okay, we're getting close. We are so close I can smell it. The last example. The last. What do I need to sub in here? There's lots of examples. There's so lots of examples left.
8.
H is what? 15. What else do we know? For what? Yeah. Um, 15 times 15 is 225. Divided by 5 is 45. that in case. Somebody can confirm that for me. I think that's good though.
Yeah, that's what I got.
You said that without even trying it. Oh, okay. Remember he did that to me earlier in the year? He's like, yeah, that's perfect, Michelle. Yeah, keep going.
I did do that.
I know.
I'm no longer that bad of a person.
See, now I didn't use decimals for this one.
Wonderful. You didn't?
But like, why did we know this?
Because, I know what you're saying. It's coming to me is what you're saying. Okay. Okay, so I'm finally getting what Jason's saying. Sorry, take care. So Jason said to me over here, he was going to say, Mr. Sadler, why'd you leave it? Like, why'd you give me a decimal here? You could have just left it like this if you wanted to. That'd be correct. Okay, right? But generally you want a number for that, okay, for that. I'm not going to force you. If you want to leave it an exact value, because this is an exact value, you can leave it like that. This one here, just get in the habit of it. As soon as you see pi in the question, don't sub in pi, just leave it as a pi. And that's just sort of a life lesson for it. Okay, I'm going to stop for right now, if that's okay. All right, you got a few minutes to work. Now, Callan, tomorrow, you're going to be bringing your calculus hat with you and be ready to work for tomorrow. All right, and everyone here, I'll give you guys a lot of time to work. I'm going to do whatever types of questions you want to do beforehand. All right. The only way this one could be worse on your test card to give you the radius too. Okay, so give you a number for the radius. That'd be the only thing that's different. Yes. Oh, sorry. Pause this video first and then. 26.